easy day. I've been very thankful for this minimum day Friday, particularly. It's been a good day. All right, guys. So we're going to go through these. Even if we did them yesterday in class together, there are quite a few of you guys working off to the side, like Albert and Tyrell and stuff. Yeah. That were not necessarily paying attention. So just in case, I'm going to get these ones again, and then it'll also let you guys double check. So on the solve ones, remember when they're equal to 0, I said yesterday, when we are equal to 0, we want to get rid of denominators. Denominators are not our friends. We just need to make sure that we watch out for excluded values. So on number 1, and this is going to be like our standard video, I'm not going to go from page to page, so I can just keep my questions right here. When I'm done with the question, I'm then going to delete the question and clear it off, and then just move to the next one. Yeah. So 12 over t plus t minus 8. Obviously, I can't divide by 0, so on number 1, my excluded values, and I'm going to abbreviate that to exval. T can't be 0, so my excluded value is t equals 0. Other than that, in order to get rid of that denominator of divided by t, I'm going to multiply both sides by t. So let me go ahead and rewrite this. So I'm going to multiply both sides by t, and that's because I equal 0, so I just want to get rid of that denominator. So those cancel. Just in case you guys still have any bad habits left over, I know for my Algebra 2 kids who also shouldn't be doing this, a lot of times when they distribute, if something cancels, all of a sudden they think it doesn't move on to, it doesn't, like it stops distributing too or something. Please make sure you don't fall into that mistake. T times t is t squared minus 8t equals 0. I have a quadratic. I'm just going to put it in order so I can recognize it for what it is and just feel comfortable about it. So at this point, we can say multiplies to 12, adds to negative 8. That's a very easy factor. What is it, Aaron? 2 and 6, yeah. So this is going to be t minus 2 and t minus 6. Right? Because negative 2 times negative 6 is positive 12, and negative 2 plus negative 6 is negative 8. So our solutions are t equals 2 and t equals 6. Neither of those are 0, so those are simply our solutions. Any questions on that?
That's all.
Yeah?
When we're doing it like on a test or something, can we skip straight from the t minus 2, t minus 6 equals 0 to the answers?
No, I'd want to see the factor. From there, I don't want just to that.
No, I know. I'm not saying skip, but I'm saying instead of setting them both equal to 0, can we skip that step?
Yeah, I didn't set t minus 2 equals 0, t minus 6 equals 0. Yes, you could skip straight to that step. That's absolutely acceptable. Just respond to an email. Sometimes it's like I love / hate, like the fear I put into students. You know, I have a student who's absent today and homework is due. They're emailing me, say, "Can I send pictures of it to you?" So it's like you could just turn it in Monday. I appreciate
You're actually very nice.
the effort, but
Yeah. Come to do this. You can't afford it.
so
Mr. Bates.
yeah,
Palpatine 66.
yeah. It's my name and number. All right, number 2. Number 2, so my excluded values, and if you finished all the homework, you can just double check my excluded values. Each of my denominators is equal to 0, but the first denominator, this one right here, n squared minus 1, is already n minus 1, and it's also n plus 1, so I really just have n minus 1 times n plus 1 equals 0, and my excluded values are 1 and negative 1. So those are my excluded values because I factored that n squared minus 1. So now I'm going to go ahead and rewrite my equation. I'll move in just a moment, Sada. I think this is one of the ones I did yesterday in class. It feels familiar. So remembering that n squared minus 1 is our difference of two squares, multiplying both sides by n squared minus 1. When I distribute, this one's going to cancel. The only thing left here, that n minus 1 will cancel, and I'll still have an n plus 1 left over. Here the n plus 1 will cancel, and I'll have n minus 1 left over. I remember why I remember this one, because you asked it. Oh, the 10. The 10. Yeah, you asked me. No, you asked it. You asked it not in class. You asked it like before school or something along those lines. It was a one-on-one there. Okay. Right, and you'd forgotten like the n plus 1 or something like that. So we distribute, we distribute, we distribute, we distribute. I'm going to combine like terms in one step as well. So you just have to be careful. I don't know, Sada. So here I'll have 2n squared, and then I'll have plus 2n minus 5n gives me minus 3n. And then negative 5. 2n squared, bless you, minus 2n plus 5n gives me plus 3n minus 5. What's nice here is that I'm going to bring everything to the left side. 2n squared, 2n squared, minus 3n, minus 3n, plus 5, plus 5. Gesundheit. Cancel, 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 cancel. That's not a cancel. I don't know why I said cancel in the center over here. Lucas was going to call me on it, though, so it's okay. 10 minus 6n equals 0. Add 6n, divide by 6. N equals 10. And n reduce it is 5/3. Which is not 1 or negative 1, so it's not one of my excluded values, and I'm golden. Those of you who completed number 2, is that what we got?
Yes.
Cool.
So we don't have to go back and plug in, right?
Hmm?
We don't have to go in and like go back and plug that in, right?
No, we don't have to do a double check. We don't, as long as we're not an excluded value, it should work. That's going to be different for next section. Next section's basically the same type of things. We're going to have excluded values because of the fact that we're going to be dealing with radical equations, square roots. Square roots. So the fact that we're dealing with square roots, we need to double check that the number we get doesn't cause what to be under the square root? A negative number, correct, Aiden? We're going to be double checking that. Oh, did what I said I wasn't gonna do. Do 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 do. 3. All right, so b plus 2 equals 0 and b plus 1. So I mean, excluded values. B equals negative 2. B equals negative 1. So b plus 2 times b plus 1 will be my common denominator. Yeah. Correct. Correct. You do it for any denominator with a variable.
And since those two are the same, you just write it once.
Yeah. So we have 1 over b plus 2 plus 1 over b plus 2 is equal to 3 over b plus 1. I mean, technically right here, I can just, since they have the same denominator, I can actually just add them first, and I get 2 over b plus 2 equals 3 over b plus 1. Now, if you have a fraction equal to a fraction, we can, instead of multiplying by the common denominator of b plus 2 times b plus 1, and then I'd be like, the b plus 2 cancels and all that stuff, you can actually look at this as a fraction equals a fraction and simply do what we learned a long time ago. Cross multiply. And you'd end up with that exact same thing. So b is negative 4, which is not negative 2 or negative 1, so I'm golden. Golden. There's already a stolen pen. Alrighty. Any questions on 3? Four. Here we have 2. So we're going to have our excluded values are going to be 3/2 and -3/2. To talk about what Lucas was referring to earlier, I just set my denominators with variables equal to 0. And I'm going to get q is -3/2 and q is +3/2. So as long as I don't get those, I should be good. Seems. So I have 2q over 2q plus 3 minus 2q over 2q minus 3 equals 1. So those denominators don't match, so my common denominator is going to be 2q plus 3 times 2q minus 3. It was good. I didn't have to go trick-or-treating. I had a headache the whole time, and I had class still, but it was still good. I didn't have to go out in the cold and walk around. Very happy. I just sent my kids out for the first time ever and go. Leave me alone. Yeah. No. My kids started at 5. So we were done at 7. So I distribute. My 2q plus 3 will cancel, and all I'll have is 2q times 2q minus 3 minus 2q times 2q plus 3 equals. I need to move this a little bit to fit it all. Here I have 2q plus 3 times 2q minus 3. All right. That one was a little bit longer. So I'm actually, even though I said I'm going to just kind of go through, I'm going to pause for a second right here and make sure that we understand why I got what I got. It's the same exact process I've been doing, but this one appears more complicated, so I just want to make sure you guys get it. Huh? It's because of the q's and the fact that I'm multiplying by like two binomials. Lots of distributions going to occur. Lucas, you have a question?
It goes into the 2q times 2q minus 3 because it's just taking it gets rid of the bottom
Correct.
denominator, right?
Right.
Because the numerator because it cancels out.
Right.
But you have to keep that original 2q.
Right.
Okay, cool. So like you have but the reason you have both is because there's both you're multiplying.
Right, on the first one, the 2q plus 3 cancels with the 2q plus 3, but the 2q minus 3 is left. And on this one, the 2q minus 3 cancels with the 2q minus 3, but the 2q plus 3 is left. Yeah. And on the right side, nothing cancels, so they're both still there. Times 1, right. Yeah. So I didn't put the 1 there if you want. Yeah. So, lots of distribution. 4q squared minus 6q minus 4q squared minus 6q equals, lots of distribution. We have 4q squared minus, these are conjugates, so there's no middle term. Minus 9. Sure. Yeah, a lot of this. What's up, Sada? Well, 2q times 2q is 4q squared. 2q times -3 is minus 6q. Negative 2q times 2q is negative 4q squared. Negative 2q times positive 3 is negative 6q. Yeah, just distributing. Yeah, I didn't put my arrows. I can and I did. So just happily cancel all along. Let's move the. I guess I'll do 2 steps. So I've got 4q squared plus 12q minus 9 equals 0. So that is going to factor very well to 3 halves and negative 3 halves, which means this will have no solution. This factors into 2q. No, it doesn't, actually. I apologize. So multiplies to negative 9. That's only positive 3 and negative 3. Or positive 9 and negative 9. That might not factor. It's this, because multiplies to 9 adds to 12. Oh, but we got the 4 in front as well. So actually we got 4. I'm not seeing whether or not this factors simply at the moment.
I did the quadratic formula.
Did it end up being pretty solutions?
No.
No. Okay, well then I'm not going to factor it. Thank you. I'm glad you already did it. So.
So I could get something like this, but just
No. Well, we got to solve it. We got to find our values of q, so we are going to have to use the quadratic formula then. Yeah, I'll use the quadratic formula. Well, I wonder whether or not completing the square would make my life easier. I'm going to complete the square just because of the fact that those of you who did it might have, if you've done it already, you might have used the quadratic formula, so this is just another method. So I'm going to bring my 9 over to the right side and divide everything by 4. So I have q squared plus 3q is equal to positive 9/4. So I moved the 9 to the right-hand side and divided everything by 4. Moved the 9 to the right-hand side and I divided everything by 4. So from here, to complete the square, I divide that by 2 and square it, so I get plus 3 halves squared plus 3 halves squared to both sides. This is now a perfect square. Q plus 3 halves squared is equal to 9/4 plus 9/4. So that's 18/4. Square root both sides. Square root of 18 is 3 square root 2. So we get 3 square root 2 over 2 when I square root both sides. Plus or minus. And then I subtract 3 halves and I'm done. I don't like that. There we go. For me, this is those rare instances, guys, and it just kind of goes to show those of you who are going for careers in sciences and whatnot, you guys lend yourselves towards the quadratic formula because it's a process that you can follow and understand, and it will find the correct solution. For me, completing the square quite often, because of the fact that I'm not intimidated by square root of 18, and I'm okay with these fractions and whatnot, I can do that much faster than putting in b squared minus 4ac and all that jazz. So that's just being familiar and working with. Okay. So that was probably the hardest one out of 1 through 5, or at least the longest one. We did 5 in class yesterday, but just for the purposes of the video, I'm going to go ahead and do 5 again right now. Really quick, this class is over at 10:54, so I'm still doing good on time. So number 5, we've got excluded values. We did this yesterday. M equals 0. M can equal 0 for number 5. Multiply everything by 12m to get rid of it. So get rid of the denominator, I mean. We need subject antecedent agreement here. Can't just use pronouns with no reference back to what I'm talking about. Well, actually, I don't need to do common denominator. I'm going to do it a little different than I did yesterday, just because I'll use that cross multiplication rule that I used a second ago. So you guys just see it a different methodology. Okay, so since they have a common denominator, I'm going to get negative 9 plus 1. That gives me a negative 8. So I've got 6m minus 8 over 3m is equal to 3m minus 3 over 4m. So I'm just going to cross multiply. I think I could have done that on the last one too. And so to make sure we get our pickle juice cleaned up before the end of the period.
It is picked up.
You're completely missed where it's at. So I get 4m times 6m minus 8 is equal to 3m times 3m minus 3. So we get 24m minus 24m squared minus 32m equals 9m squared minus 9m.
When doing that, do we have to write the middle step, or can we go straight to?
If you can distribute in your head, you can go straight to this. Get it equal to 0, so I'm going to subtract 9m squared, add 9m, subtract 9m squared, add 9m. I'll move this to the left so I can continue working. (24 minus 9, I get 15m squared. Negative 32 plus 9, I get minus 23m equals 0. Factor out the m. I get m times 15m minus 23 equals 0. That gives me an m equals 0. And 15m minus 23 equals 0. M equals 0 is an excluded value. Can't use it. Add 23, divide by 15, and m is 23/15. That's ugly, but that's our solution.
So I had it right. I did it the wrong way, but I had it right.
You said that yesterday too, yeah. There's no necessarily if it's mathematically appropriate. If it's mathematically appropriate, then it's not the wrong way. You just did it a different way. Yes.
So what was the part with the after you factored out the m, you said the m equals 0?
Right. So remember, when you have like the double parentheses, this parentheses equals 0, this parentheses equals 0. That's technically a thing in parentheses. So this equals 0, and the other one equals 0.
Thank you.
Uh huh.
How much time do we have, Mr. Bates?
A lot.
Okay. 12 minutes.
12 minutes. I forgot what I said already on time. 54. Yeah, 12 minutes. All right. So I'm halfway through. Let's get to decompose into partial fractions that they're working on over there on the board. So we have x minus 6 over x squared minus 2x. So this is going to be x minus 6 over x times x minus 2. So this is a over x plus b over x minus 2. So I factored x squared minus 2x into two different things. No, it doesn't matter. So obviously I'm going to multiply both sides by that denominator. So I have x minus 6 on the left equals a times x minus 2 plus b times x. And that's the same concept that we talked about earlier on what one thing cancels, one thing does not. Sada, question? Which one? I want to get rid of all denominators, so I multiply by the common denominator. This has an x times x minus 2, and that's going to cancel the x and the x minus 2 as well here. So now I want to cancel out a, so I'll let x equal 2. So I get 2 minus 6 equals, this cancels a, so I'm just going to write b times 2. Negative 4 equals 2b. B is negative 2. Then let x equal 0, because I want to cancel out b now. So if x was 0, b would get canceled. So now I get 0 minus 6 equals a times 0 minus 2, and b is gone. So I get negative 6 equals negative 2a, and a is 3. How do I know to go where?
Like, let x.
I want a gone. What would make this 0? If x was 2, then A would be multiplied by 0 and A would become canceled.
Okay.
Oh.
What did
Okay, so how did you know which one to place the x under and
Doesn't matter.
-2?
Because
I still have it wrong.
what'll happen is it would have been flipped. I would have gotten, if I swapped them, this would have just said A is -2 and B is 3. Because at the end, A is what's over x, so I get 3 over x. And B is a -2, so -2 over x minus 2.
Is that all?
Yep. Yep.
What was that you just did? We got the answers there, or the
I put A and B into right here.
right.
And is that your final answer?
Mm-hmm.
So when the original fraction or the equation or whatever, when it doesn't equal 0 or a different fraction, it's always going to equal the A over x plus B
Yeah.
over x minus 2. Okay.
All right. Seven. We have -4y over 3y squared minus 4y plus 1. And then I leave that blank up there for my answer later. All right? So down here, I'm going to put my factored form. So that's going to be 3y minus 1 times y minus 1. Because 3y times y is 3y squared. Minus 3y minus y gives me my -4y. -1 times -1 gives me my +1. So it's going to be equal to a over 3y minus 1 plus some number b over y minus 1. And Lucas, if you get good at factoring, you'll be able to factor it like this, and you'll be able to skip to the -4y equals, right? Because I'm about to multiply both sides by this. One thing cancels, one thing stays, one thing cancels, one thing stays, and you get seeing that pattern, and you just go with it. Indigo? But if you factor a 3 out, you'd get y squared minus 4/3 y plus 1/3.
No, I didn't factor it. I just multiplied it to because I don't know how to factor with the coefficient that's not one. So I looked it up and it said that you could just multiply your a minus c and then factor what she did.
Oh, right. So I mean, factoring, this is a times c, and this is going to be your b value. And this is still going to be 3, and this is still going to be -4. What multiplies the 3 and adds to -4, you're going to get 3 and 1. So they're both negative. So well, then you got to do a box. That's factoring's not algebra 2. Factoring's other stuff. So if you know what you're doing, you're good. Okay. All right. So I'm going to multiply by this denominator. Oh, I grabbed the y. Let me do that. So I get -4y is equal to a times y minus 1 plus b times 3y minus 1. Let y equal 1 so I can cancel the a, because 1 minus 1 is 0. And I get -4 times 1 is equal to b times 3 times 1 minus 1. So that's -4 is equal to 2b. And divide by 2 and you get b is -2. Now to cancel this one, I need to let y be 1/3. I need to let y be 1/3 to cancel out my b. So I'm going to get -4 times 1/3 is equal to a times 1/3 minus 1. So I get -4/3 is equal to 2/3 of a. Well, that just means a is also -2. A is also negative 2.
This number is
Hmm?
Is that a 4 or y?
Where?
In the beginning.
This is a 4.
That's a negative 2, right, for B.
A is negative 2.
And so is B, correct?
And so is B.
Okay, I was making sure.
And so is B. So I get negative 2 over 3y minus 1 minus 2 over 3y, or sorry, over y minus 1.
Yeah, we rewrite it.
Huh?
We rewrite it.
Yeah, that's the final answer is broken down into partial fractions, so we get our 2 partial fractions that make it.
We wouldn't get credit if we were to just do the A equals.
No, that wouldn't. That would be if you did it all correctly, that'd be half. But you need to give me that final answer. Yeah,
Yeah,
it's
so
up here.
what was
This
the last
is.
one? Yeah,
You have to put A and B back in and give me that.
Oh, you just write over the same thing.
Yeah,
Just the left part of the.
that's the original equation. It is part of the answer. Yeah, yeah. It'd be like it's just a full sentence thing. Like if I said y equals 2x, or sorry, f of x equals 2x plus 5, and I said what's f of 3, and you wrote 11. F of 3 equals 11 would be the correct, right? Yeah.
Yeah, that's what I'm wondering too.
Oh, so it's positive 2?
Yeah.
Okay. There you go. My apologies. 1/3 minus 1 is negative 2/3, so I'd make it a positive 2. My apologies. Eight, 9, 10. I might have to pause for the video, and then I'll obnoxiously do it while 6th period takes a quiz.
No worries, an ASMR.
There are 2 more sections, Tylee. So you're probably looking at Thursday next week.
I'm so sad. I'm so bad.
So sorry guys, you're gonna have to just listen to me as I go back over this. So we're moving on to number 8, solving inequalities. So these ones are gonna be test points. So we want to get a common denominator on these. So our first test point is going to be w equals 0, where our denominator equals 0. We have 2 over w plus 3 greater than 29 over w. Let's get our common denominator. So we have 2 over w, 2 over w plus 3w over w is greater than 29 over w. Get it equal to 0, and I'm going to put it all under one denominator. So I'm going to get 3w minus 27 all over w is greater than 0. So 3w minus 27 is my other test point. This is going to give me w is equal to 9. So my test points are 0 and 9, so I'm going to pick things less than 0, between 0 and 9. So for w less than 0, w is between 0 and 9, and w is greater than 9. So if I pick something less than 0, I'm going to get a negative over a negative, which is positive. That one works. For between 0 and 9, I'm going to get a negative over a positive, which is negative. That's not going to work. And for w is greater than 9, I'm going to get a positive over a positive, which is positive, and that does work. So my solutions are w is less than 0 and w is greater than 9 are my solutions, because that's what works. Number 9. I have x minus 3, x minus 4, x minus 5. That is the bell. That's 1206. Yep. X minus 6 squared less than or equal to 0. My test points are X equals 3, x equals 4, x equals 5, x equals 6. So, gotta pause it again while I collect papers.
Honestly, I think this is my best
I
friend.
did. I did not finish it.
Is that a good thing or a bad thing, Schnitger?
That's
Can I see any physical test, Mr. Boots?
A couple minutes, but I can't give you much more than everybody else here.
Okay.
How'd it go, Miss Kim? How did it go?
Here you go.
Continuing on, my test points are 3, 4, 5, 6. So I'm going to choose things less than 3, between 3 and 4, between 4 and 5, between 5 and 6, and greater than 6. So x is less than 3. X is between 3 and 4. X is between 5, 4 and 5. Just put it in the correct stack, yes. X is between 5 and 6, and x is greater than 6. And I'm looking for less than or equal to 0. So less than or equal to, so it's got that equal to, so my numerators can be. So first of all, x equals 3 and x equals 4 will make me equal to 0. So those are two solutions. So less than 3. Less than 3. I'll get a negative. Negative. Don't watch out for that squared right here. Let's make anything in there positive. Negative. Positive. That makes a negative, so this is one test point that works. Then we've got between 3 and 4, I'll get positive, negative, negative, positive. That makes positive. That one does not work. Between 4 and 5, I'm going to get, between 4 and 5, I get positive, positive, negative, positive. That makes a negative. That does work. Between 5 and 6, I'll get positive, 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 positive. That makes positive. That doesn't work. And greater than 6, I also, once again, between 5 and 6, no, that's good, yeah. Greater than 6, I get positive, 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 positive. That makes positive, that does not work. So my solution is values x is less than or equal to 3. Because of this equal right here, guys, I brought that in along with the less than. Okay? And then x is 4 and 5. So x is greater than or equal to, once again, I brought in the equal to from the 4 and 5. So that's kind of a cool one. I like it. Oh. Number 10. Seven over y plus 1 is greater than 7. So my test point is negative 1 right now. I'll get my other one when I subtract 7 and get a common denominator. So I have 7 minus 7 times y plus 1. I'm just getting a common denominator. All over y plus 1 is greater than 0. So 7y and a negative 7, so I get negative 7y over y plus 1 is greater than 0. So another test point is y equals 0. Up here, my test point was y equals negative 1, y equals 0. So y is less than negative 1, y is between negative 1 and 0, and y is greater than 0. I'm substituting these into this equation down here. So when y is less than negative 1, I'm going to get a positive over a negative, which is negative. I want values greater than 0, so this one doesn't work. Between negative 1 and 0, I get a positive over a positive, which is positive. That'll work. greater than 0, I get a negative over a positive, which is negative. That doesn't work. So my answer is y is between negative 1 and 0. 11. The ratio of x plus 2 to x minus 5 is greater than 30%. Just remember that we're dealing with the percentages, so I'm not going to put it in decimal form. I'll just remember that I'm in percentages. So going to subtract 30. Get a common denominator. This is just like number 10. I'm just showing the steps a little clearer here because we did 10 yesterday in class. So we have x plus 2 minus 30 times x minus 5 all over that common denominator of x minus 5. So we have x plus 2 minus 30x plus 150 all over x minus 5 is greater than 0. So really quick off the top, my test point here was x equals 5 because of that. We're going to have a different test point from the numerator on this one. I'm going to shrink this just a little bit, move it over. Combine like terms, I get negative 29x plus 152 over x minus 5 greater than 0. So my other test point is negative 29x plus 152 equals 0. Subtract 152, divide by negative 29, I get negative 152 over negative 29. 29 is prime, but does it go into 152? Let's see, 6 would give me 120. No, it's not going to go in. So x is 152 over 29. But let's get a ballpark estimate just so we can pick some good test points. So let's say, well, that's about 5.2-ish. So I'll pick something. So 5 and 5.2. So my test points, x is less than 5. X is between 5 and 152/29. And x is greater than 152/29. So a number less than 5. So remember I'm plugging it into here. I want greater than 0. If I pick a number less than 5, I'll get a negative over a negative. And that's positive, and that works. If I pick something between 5 and 152/29, I'll get a negative, or sorry, I'll get a positive, right? I'll get a positive over a positive, which is positive. That works. Maybe when I pick something less than 5. Oh, when I pick something less than 5, I'm sorry, I'll get a positive over a negative. That's a negative. That doesn't work. Didn't realize. Doesn't work. Okay. And I pick something greater than 152/29. I'll once again get a, well, I won't once again. Let's see. I will get a negative over a positive, which is negative. That doesn't work. So my answer is only x is between 5 and 152/29. There we go. All right. Have a good one. Enjoy your weekend.